In this video we're going to look at the double intercept method, how we will use that to draw a straight line. We've already used a table to draw a straight line. It is tedious, it is a useful tool if we want to find out the behavior of other functions, like for instance a parabola and hyperbola, etc. But we are always interested in the x-intercept and the y-intercept of a function. So in this method, we're going straight and calculate the x-intercept and the y-intercept. If we look at this equation here, 6x minus 3y equal to 9, we can rewrite the equation as a standard form y equal to mx plus c, and then find the intercepts by substituting x equal to 0 for the y-intercept and y equal to 0 for the x-intercept. Let us find the standard form of this function first. To find the standard form, we must isolate the y in this equation. So we can just keep the 3y on the left hand side, minus 3y, and take the minus 6x to the other side, and then divide by minus 3, then we get an equation 2x minus 3. We can label this number 2, equation number 2, and the standard form is y equal to 2x minus 3. In this case, we can read off the m value and we can read off the c value. If we look at the y-intercept and we put x equal to 0 into number 2, we see that y is then 2 times 0 minus 3, and that is minus 3. And that is exactly why we say that the c value is minus 3. If I then look at my x-intercept and I want to make y equal to 0, I get 0 equal to 2x minus 3, and I solve for x and I get 3 over 2. So the coordinates of the x-intercept is 3 over 2, 0. And the coordinates of the y-intercept is 0, minus 3. So I'm just going to transfer these values here. But we can always draw a straight line through any 2 points. So we need an extra point just to make sure that we're accurate. I always take something that's easy to compute, so I put the x equal to 1 in there and I get a value of minus 1 for my y. I have the 3 points there, and now I can plot it on my grid, and in this case x is equal to 3 over 2, which is 1.5, and the y-intercept is at minus 3, and I have another 1 minus 1 there. And in this case, I can draw a straight line through these points, and if they all lie on the same straight line, then I know my computations was correct, and then I just label my graph, and then I'm done. If I don't have a grid, then you have to add the values here on the grid. So if it's a sketch graph, for instance, if you have this, then you will, for instance, write the 3 over 2, and you will do minus 3 there, and you will draw your line and label it. And you will just check whether it's correct. In the case of the double intercept method, it is not crucial to reduce the equation to standard form. I can just leave it as 6x minus 3y equal to 9, and I can work out my y-intercept by putting x equal to 0. If I put x equal to 0 in 1, I will get 6 times 0 minus 3y equal to 9. So I'll get minus 3y equal to 9. So y will be minus 3. If I put y equal to 0 in that equation, I get 6x minus 3 times 0 is equal to 9. I get 6x equal to 9, so x is equal to 3 over 2. Only problem with this method is you cannot read off the values for m and c, And still we just have two coordinates here. So again, you can compute another value. You can, for instance, put in y equal to 1. Then we get 6x minus 3 times 1 equal to 9. And then we compute x. Normally we will put something for the x and then compute the y. So x is equal to 2. So this coordinate here, I'm just going to write it again here. So we have three coordinates. The one is 3 over 2, 0. The other one is 0 minus 3. And here we have x equal to 2 and y equal to 1. So if I now plot these values, again we have the 3 over 2 somewhere here and the minus 3 here. And if x is 2, then y is 1. And if I now take my ruler, these three dots must lie on the same line. So I just join it and I label my graph. Right, formula, which is 6x minus 3y equal to 9. It looks, however, better to have the function y equal to mx plus c, but there's nothing wrong with this.